Okay, so we've had a look at a few different types of factoring. We've done highest common, difference of squares, monic, quadratic. Now we're going to have a look at non-monic quadratic factoring. So a quadratic, we said, was an equation of the form ax squared plus bx plus c, and this is where a, b, and c are included in the reals. So a, b, and c are numbers. If a was equal to 1, so we said that if a was equal to 1, then the quadratic became what we called a monic. And we saw methods for factoring monics by breaking them into alpha and betas. We found alpha and betas that added to give the b value and that multiplied to give the c value. But if a is not equal to 1, then this is what is known as a non-monic. And non-monic quadratics are slightly harder to factorize. Now, of the non-monics we're going to be dealing with, in the advanced maths course, you will see two different types. Some are trivial. A trivial non-monic, as we saw at the end of the last video, was something which could be factorized into a monic. Pretty much they're going to be factorizable with relative ease. If something is non-trivial, trivial, it's been spelled trivial, right? Non-trivial, it can't be factorized easily by the squared term's coefficient to turn it into a monic. For these quadratics, we have a different method, which is sometimes called the cross method or the separation method. So we're going to talk about the separation method. Separation method for solving non-trivial, non-monic quadratics. So let's write down an example of one of these equations. The separation method is best shown with an example. So we'll write down one that's not overly complicated. We'll do 2a squared minus a minus 3. Now we could try dividing everything by 2, but it's going to leave fraction coefficients. The 3 doesn't easily divide by the 2, so probably that's not going to work. What we need to do in the case of a non-monic that's non-trivial is we need to look at the a value, which is equal to 2, the b value, which is equal to -1, the c value, which is equal to -3. We need to multiply a by c. So a is 2, c is 3, or -3. 2 times -3 is -6. Now, the separation method works by separating. We are going to separate the -a term into two separate terms. And the two separate terms are going to have the following quality. The two terms we separate the a into, which I'll refer to in this case as x and y, are going to multiply together x, or we'll do the proper x here. We'll say x times y. The coefficient of x times y will be -6, and the sum of x and y, x plus y, will actually be equal to the b value, which is -1. So we multiply the term out the front and the term at the end. That tells us what the product of the two terms will be that the -a becomes. And then the number in front of the -a, the coefficient of the -a, that tells us what they sum to. Because we have to break -1 into two terms, they must combine to make -1. So if we think of pairs of numbers that multiply to give us the number -6, we have -6 and 1, we have 6 and -1, we have -3 and 2, and we have 3 and -2. Well, of these, -3 and 2 is the only one where the two numbers add to give -1. So we're going to take this non-monic, we're going to rewrite it as 2a squared, first term remains the same. The -a will become, will separate into two terms. So it's going from -1a to -3a, the first term here, plus 2a, the second term here. and then we have the minus 3 at the end. So by separating this middle term, what we've done is we've created a pair of numbers at the beginning, which we can factorize, and a pair of numbers at the end that we can factorize. And if we did this separation appropriately, once we start factorizing everything that remains, we should actually be able to factor the whole expression several times and put it into a properly factored form. So we'll factorize the first two terms. We can take an a out of them. So we have a, 2a squared divided by a is 2a, minus 3a divided by a is minus 3. And for the second term, we can take only the number 1 out of them. There's nothing. So we have plus 1 times 2a minus 3. This is where the magic happens in this method. When we factored the first terms, we got a 2a minus 3 in the brackets, and we also got a 2a minus 3 from the second set of brackets. If you've done this method correctly, this will always happen, where the first term of brackets is the same as the second term. Of both of these expressions, of the expression a times 2a minus 3 and 1 times 2a minus 3, they both have 2a minus 3 in common. So we can factor that out the front. So we get bracket 2a minus 3 times, well, the first term remaining in the first expression is a, the term remaining in the second term is plus 1. And then we can write this as 2a minus 3 times a plus 1. So this is the separation method for non-monics. This is a much harder method. What you're doing is you're breaking that middle term, the linear term, into two separate terms using the process we saw here, using the x and y. Once you've got that, you're factoring the first two terms, factoring the second two terms. If you've done it correctly, you'll then be able to fully factor the whole thing. Now, we might choose to check this. This is a fairly long method, and we don't really want to have the answer wrong. So we can check this at the end to confirm that the answer solution is actually right by FOIL expansion. 2a times a is 2a squared. 2a times plus 1 is plus 2a. Minus 3 times a is minus 3a. Minus 3 times 1 is minus 3. This gives me 2a squared minus a minus 3. And you'll notice this 2a squared minus a minus 3 is actually the thing that we started with up here. So this is definitely the correct factorization. All right, so let's have a go at some of these questions. So I'm going to write 2 down. I'll let you have a go at them, and then we'll go through them. This method, you do need to do it a lot. So you need to do it again and again and again to get used to what's going on. So for question 1, you can have a go at, let's pick 3x squared plus 16x plus 5. And then for question 2, we'll make the second one a little bit harder. You can have a go at 4x squared plus 14x minus 30. All right, so pause the video now and have a go. All right, so now that you've had a go at these, let's go through them. I'm going to move this second one a little bit further down the page to give myself a bit of working space with the first one. We're going to use the separation because this is not easily factorizable into a monic. So it's a non-trivial non-monic. We need to split this 16 into two separate terms. The two terms, which we'll call x and y, have to add, the coefficients of them must add to make 16, and the coefficients of them must multiply to make the term out the front times the term at the end, 3 times 5, which is 15. So we're looking for two numbers that add to make 16, multiply to make 15. Well, if we think of factorization pairs, 15 times 1, well, that already works. 15 plus 1 is 16. So we get 3x squared. The 16x will be broken up into 15x and 1x, the sum of these. The order that we do the factoring at the end, by the way, doesn't matter. You could put the 1 first and factor the first two with the 1, or put the 15 first, factor the first two with the 15. You'll pretty much end up with the same thing. You'll end up with a mathematically equivalent expression in the end. So we'll do 3x squared plus 15x plus 1x plus 5. Factorize the first two, factorize the second two. So the first two, we can take 3 out of both of them and an x. We've got 3x. 3x squared divided by 3x is x. 15x divided by 3x is 5. There's a plus between them. The second two, we can only take a 1 out of both of these. So we end up with x plus 5. This is x plus 5. This is x plus 5. We bring that out the front. X plus 5. And then the second bracket will be the first term here, 3x, plus second term here, 1. And once you're at this final step, the color coding is really this and this in brackets were the same. So it goes out the front. The term which was in front of the first bracket is the first term in the second bracket, and the term that was in front of the second bracket is the second term in the second bracket. So this process, once you're at the end, always works. And this is our factorized form. Now for question 2, this one is a little bit unusual. It is slightly simplifiable straight away. So we could actually divide the whole thing by 2. So divide everything by 2. This would give us 2 times 4x squared divided by 2 is 2x squared. 14x divided by 2 is plus 7x. Minus 30 divided by 2 is minus 15. So by making these coefficients smaller, we have reduced the amount of work we have to do using the separation method. So we still need to separate this. The 7x is going to be split into 2 terms. So the 2 terms will be such that the sum of their coefficients will be 7, and the product of their coefficients, x times y, will be the coefficient of the x squared term times the n term, will be minus 30. So let's think of pairs of numbers that multiply to give us minus 30. Well, minus 30 and 1, 30 and minus 1, 15 and minus 2, 2 and minus 15. We've also got minus 10 and 3, or 10 and minus 3. Well, 10 and minus 3, sum of those is 7. So these will be the 2 terms. So this will end up being 2 times 2x squared plus 10x minus 3x minus 15. Notice I put the 10x first instead of putting the minus 3x first. Could have been done either way. And actually, we'll show that this is true both ways. So if we put the 10 first, this ends up being 2 in front of 2x squared plus 10x minus 3x minus 15. If we did it in the other order, we would get 2 in front of 2x squared minus 3x plus 10x minus 15. So let's factor both of these concurrently. So first 2 terms, second 2 terms, we get 2 in front of. Factorizable from 2x squared plus 10x is 2x. 2x squared divided by 2x is x. 10x divided by 2x is 5. Factorizable from minus 3x and minus 15 is minus 3. And we are left with minus 3x divided by minus 3 is x. Minus 15 divided by minus 3 is plus 5. These are common. So we end up with 2. X plus 5 is the first bracket, and 2x minus 3 is the second. Now, for this one, we have a coefficient out the front. So what we might choose to do is we might choose to make the coefficients of all of the x's equal to 1. We're going to do this by dividing everything in this one by 2. So we end up with 2 times 2, which is 4, times x plus 5, times 2x divided by 2 is x, minus 3 divided by 2 is minus 3 on 2. So this is our solution. For the other rearrangement, we had this was equal to 2 times factorizable from the first 2 is only x. X in front of 2x minus 3. And then factorizable from the second 2 terms is minus 5. we'll just make it positive 5. Yep, plus 5. This will give us 2x minus 3. 2x minus 3, 2x minus 3. So we have 2x minus 3 is our first term. X plus 5 will be our second. X plus 5. If we factor 2 out of this, divide everything in here by 2, move it to the front, this becomes 4 times x minus 3 on 2 times x plus 5. Now you will notice both of these are exactly the same. They're the same. And the reason they're the same is it didn't actually matter which way you went with the arrangement of those two terms when you did the separation. If you factor the thing correctly, you will get the right answer in the end. It will also be more common to write this as your answer, or this. And this is something I always tell my students. When you talk to your friends in your maths class and you're doing the factoring for non-monics, you will sometimes end up with different answers to your friends, but you will both be correct. That's something you need to look out for. If you are factoring them like this, but not making all of the coefficients of all of the individual x terms 1, you could end up with different looking things. Either the order is different, but they're the same things, or you could actually end up with different looking brackets in the case of quite complicated non-monics, which are equivalent if you factorize them to make all of the coefficients of the x terms equal to 1.